I think before you start this video, well, you've already started it, but I think I would push pause and work on these problems. There's 8 problems on this page because this is the easy page. You'll see on the next page they get quite a bit harder, but this is just direct application of the rules above. So I would press pause and I would go through and see how many of these you can do. Try all of them. I mean, there's nothing wrong with getting something wrong. That's how you learn, is from your mistakes. But go ahead and shut off the video and work on these 8 and then turn it back on and join me. Okay, this first one is just like this one. The exponent only goes with the 2, so it's read the opposite of 2 squared. So there's 1 negative and 2 2's, so the opposite of 2 squared is negative 4. Where this one is just like my first one, it is negative 2 times negative 2 because of the parentheses. That means the negative's used twice and the 2's used twice. Where this one, the negative is only once and the 2 is used twice. So see the difference? Be a lot if you had $4 million or were $4 million in debt. So that little sign makes a big difference. Okay, next we have the quotient rule. So this is the power of a quotient that we did up here. So that exponent outside, remember, gets distributed to everything inside. So this negative does need to remain in parentheses. So this will be negative 1, and these are both to the first power. So 1 times 4 is 4. And then 3, 1 times 4 is 4. Some students would rather write negative 1/3 times negative 1/3 times negative 1/3 times negative 1/3, and you would get the same answer. So this is just using the properties above. Because I know you all know how to multiply, I'm using the exponent rules, but we would get the same answer. So negative 1 times negative 1 times negative 1 times negative 1, 4 negatives become a positive, and 1 times 1 is 1, times 1 is 1, times 1 is 1. So that just turns to positive 1. Even number of negatives, positive answer. If it had been 3 negatives, negative. And then 3 times 3 is 9, times 3 is 27, times 3 is 81. So on the test, I require that you show your work, but you could check your exponents on the calculator let's go over here, just to make sure. And I'll go over again how you do the exponent. So if you want to do 3 to the 4th, you type in your 3, and then this is the exponent key, caret 4, and you can verify that that's 81. Okay, so on the test, I make you show your work, but you can evaluate with your calculator. Okay, number 5, this negative is an opposite sign, just like out here. So this means negative. Because there aren't parentheses, only the 4 should be used twice, and the 9, nothing happens to it. So for my final answer, I would get negative 16 over 9. So that does not mean negative 4 times negative 4 because it's not in parentheses. So it's the opposite of 4 squared over 9. 4 squared over 9 is 16/9, the opposite, negative. This is one that's probably one of the most missed on the test. Students have a hard time with this one. So this is how I like to rewrite this one. Because to me, that's what this means. This is read the opposite of 3 to the negative 3. So opposite just means you're multiplying something by negative 1. So I know I can't leave a negative exponent. So according to this, whenever the exponent's negative, I have to move it down to the other side of the fraction. So right now there's a 1. but I need to make that exponent positive, so it needs to move down there with that one. This one does not have a negative exponent. It's not negative numbers we need to get rid of. It's negative exponents that we can't have. So a negative number's fine. So it stays right where it's at. But this exponent needs to be made positive, and we learn that you can make it positive by bringing it down to the other side of the fraction. So the 3 comes down, and then its exponent becomes positive because you moved it down. So now it turns into negative 1 over 3 times 3 times 3. 3 times 3 is 9 times 3 is 27. So that would be your final answer for number 6. So negative 1 over 3 cubed. And then here we have the product rule, which is up here, which is the power of a product. So you take the exponent and distribute it to everything inside. So this 3 goes with the 5, it goes with the x, and it goes with the y. So this would be, and these are all ones right now, 1 times 3, 1 times 3, 1 times 3, so 5 to the third, x to the third, y to the third. So 5 times 5 times 5 is 125, or you could do it on your calculator. Remember, 5 caret 3, and see it's 125. So this answer, you should have 125 x cubed y cubed. Okay, on the next one, we have a negative exponent that we need to take care of. So this needs to move to the other side according to this rule here. If we have a negative exponent, we move it to the other side of the fraction. So then what a lot of students write for their answer is x6, x4. Well, no. These will be in the denominator, and there's an imaginary 1 here because this is really 1 x to the negative 4. So what we have is 1 still on the numerator. You cannot lose that numerator and just all of a sudden pretend that those two are in the numerator. So the x to the 6th was already there. X to the 4th comes down to join it. So now what I have is a multiplication property, which is the very first property we studied. And it says when you have the bases the same, you keep the base and add the exponents. So that's going to be what we use right here. The bases are the same, so we keep the base and we add the exponent. 6 plus 4, 10. Wild, huh? So just remember, every single term has an imaginary coefficient of 1 if there is not another coefficient. This one, to make an exponent positive, remember how we said reciprocate the base? So when I reciprocate the base, y over x, that makes my exponent positive. So just like here we reciprocated it, we put it under 1. Here it's already a fraction, so we don't have to put it under 1, so we reciprocate the base, the exponent turns positive. And then we have imaginary 1s in here. Now it's just the power rule, which says to multiply. So y to the 7th over x to the 7th. And remember, you can never leave negative exponents in an answer unless it's scientific notation. So always make sure to check that you've made all your exponents positive. So this is not an exponent. Exponents are up in the air. So as long as all the exponents are positive, we're good. Okay, let's go ahead and look at the next page. So we have about 3 more easy ones, and then we have about 3 that are going to be a little bit tougher. So, what property do you think number 10 is? Multiplication rule, right? So multiplication, on the last page it said keep the base the same and add the exponents. So 3 plus -7 plus 4. So keep the base the same, add the exponents. So this is 7 minus 7, which would be x to the 0. But then another rule we learned on the last page is that anything to the 0th is 1. Let me get my front page. So this one used first this rule, multiplication rule, base is the same, keep the base, add the exponents. So that's what we did there. But then it went on to use the zero exponent rule that says anything to the 0th is 1. I'm going to keep this underneath. Okay, so here we have a quantity to the 0th. So guess what? No work needed. That one's just 1. So all of that was raised to the 0th power. Since it was all in parentheses, it's just 1. This is a direct application of the power rule. The power rule says whenever you have a number outside parentheses, you multiply them. So see this? 2 times 3, 6. So this is going to be y -6 times -2, positive 12. Nice, huh? And now we jump into the little bit more rigorous problems. So we do have number 15 on the test. This was actually one of the most missed problems last semester, so this would be a good one to stop the camera when we get to it. Maybe watch these two. On this one, stop the camera, try it on your own. If you're afraid you're going to miss it, then write it on a separate sheet of paper and try to do it first, and then check it, and if it's right, then you can transfer it over. Okay, so when I have problem like number 13, the first thing I want to do is make all my exponents positive. Students do not do well with negative exponents. Plus, I know I can't leave any of my answers with negative exponents. So I'm going to first make all my exponents positive. And remember, the negative exponent rule says anything that has a negative exponent just moves to the other side of the fraction. So these two need to get flip-flopped, and then they'll both become positive. Same thing here. These two need to get flip-flopped, and then they'll both become positive. So sometimes we just move one, like here. On number 8, we just move 1 because there was only one that was negative. But if they're both negative, then you can flip-flop them. So the 2 to the 8th needs to move down. The 2 to the 4th needs to move up. So this is going to be 2 to the 4th in the numerator, 2 to the 8th in the denominator. So that one moved up to make it positive. This one moved down to make it positive. Then we do the same thing. X to the 5th moves up. X to the 2nd moves down to make it positive. And you're probably thinking, well, why didn't she circle those? Because they're already positive. If they're already positive, don't touch them. If you moved them, you would make a negative, so you'd be going backwards. So if the exponents are already positive, leave the base exactly where it's at. Okay, so let's go ahead and apply. Does everybody realize this is now the quotient rule? So the quotient rule says keep the base, but subtract the exponents, numerator's exponent minus denominator's exponent. So that's going to leave us with keep the base. So